Well, hi, good morning, and thanks for joining me here in my shop. The last few days I haven't posted any videos on this, and it's not because I haven't been in here working on it. I have worked on this almost continuously the last couple of days, as much as I can take it anyway. And the result of that is a number of interesting observations, none of which seem to point or add up to anything. The two problems that I'm going at here, one is a basic problem with a hum. And the other one is some kind of oscillation that takes place in this amplifier. At times, radio frequency or well above our range of hearing in any case. It can be seen on the scope but not heard in the speakers. And other times, stuff coming out of the speakers. At times, based on literally what I'm doing with the probe of the voltmeter, I can touch certain spots. The hum entirely disappears. It's completely hum-free at that point, but there's these other problems going on. In terms of voltages, what I've discovered is all the voltages on the four output tubes are identical all the way across. All the testing I've done indicates everything is A-OK, even though it doesn't operate A-OK. Did I make a mistake in doing some of those tests? I don't know. I've done them 2 and 3 times. I did replace the capacitors up in here. I put in rolled style capacitors, these tubular capacitors, but what I took out was this kind of capacitor. I'm thinking it's possible that this rolled style capacitor or tubular capacitor may have some inductance, maybe causing some kind of resonant situation to occur, and that's where the oscillations are coming from. I don't know that for sure. Probably the most interesting observation, and the one I think I will start with, I will start by repeating it this morning, is the temperature of the 4 output tubes is not consistent. And it's not the tube. It's whatever tube is plugged into this socket will run significantly cooler than the other 3. And I'm going to verify that right away, because that's probably the most significant observation I've made the whole time. So looking at the 2 tubes up here, the 2 preamp tubes, it's a preamp tube and a tube designed to enable the creation of 2 180-degree out-of-phase signals to carry on to the push-pull output tubes. That's what's going on with these 2 tubes. What I find here is the grid and the plate. One of the plates, one of the grids in these tubes is joined directly together on purpose. When I test that point, I get very interesting results, which we will repeat all this too so you can see it. At times, I seem to get the correct voltage here. It's supposed to be 32 or 34 volts. At other times, I'm not getting the correct voltage. I couldn't tell you what is occurring that is making those changes. At times, I can literally take my voltmeter off and put it right back on and I get a different reading. So I'll try to repeat all that. So that's very curious things going on, mostly on this side. The problems in here do not appear to be related to the tubes I'm using. I have swapped them into all kinds of different positions, and the results don't change. It's always the same. A hum and a high frequency oscillation. I have quite a few spare 6 BQ5s. I have 10. So this is one of the originals. One of my replacements is sitting here in the cold tube position as part of my investigating of that situation. So in fact, I tested the tubes. I think that's on video. You've probably seen that. I tested the output tubes. They all work really well. In my 10 spares, 5 of them are in really good shape. I've looked for RF in the power supply, B+ line, thinking that maybe something is leaking around the radio through the B+ line. Tested it here. There's no RF in it, even when there's RF apparent up here. And in terms of the RF, or high frequency oscillation that I see, the pattern is similar from channel to channel. If I test these pairs of tubes, I get a little more here, a little less there, a little more here, a little less there. They look exactly the same, as if both of these are operating in exactly the same manner when it comes to the oscillation. But when I move the voltmeter lead around, I get different responses in terms of the oscillation coming and going. If I touch this capacitor over here, if I'm trying to remember now, with my voltmeter lead, the oscillations completely end. There is no hum in the amplifier, and it all appears to be working. I have brought the receiver in here, hooked the whole thing up. I did that yesterday, and played it to see if these issues would disappear for some reason, for some unknown reason. If I included the receiver, everything's fine. No, that didn't happen. Everything remained. The hum remained. It made no difference that I plugged the receiver in here. Gave me a chance to check over the receiver quickly. Lots of problems there too. So once I get this straightened away, I'm just into another basket of problems. I found a DC voltage floating on the wrong side of this capacitor, the output side of this capacitor, of about half a volt. This is going nowhere here. It's not hooked up to anything. There's no speaker connected to it. Nothing here in my shop. So I think the voltage is unimportant, but it probably indicates there's moisture in here. I'm not sure what to make of that. I'm really not. I've moved the wires around. For a while I had this ridiculously long wire connected to the input. Obviously I removed it. I've done various things to move and relocate these speaker wires. Nothing has any influence, except in the most minor way, on the oscillations that I see. At times, and this is quite a while ago now, so I don't know if it would still do it, I can see the oscillation on the, I can't remember now. There was a situation where the oscillation, in 4 test points, the oscillation did not appear in the last one. I've also made observations earlier on where touching the grid of these 4 output tubes causes a clicky sound, if you would expect. Touching the grid of this one did not. I thought maybe this tube was dead. More testing shows no, it's passing a signal. The way I did that was I fed a signal into the amplifier in this channel, pulled out one of the 2 tubes. You could still hear it in the speaker, no problem, even with one of the output tubes pulled out. So even though I'm getting weird voltage readings or things that might make me think there's no signal going through the tube, it is working. These 4 resistors which are going to the screens of each of these output tubes are 100 ohm resistors. One of them reads 140 ohms. The rest are around 110. The voltage on either side of them is identical, as if there's no screen current flowing in this on any of them. This style, just going up a level, the style of amplifier here is I forgot the exact word. It's a linear amplifier. In any case, it's designed ultra-linear. It's designed to be exceptionally linear in terms of frequency response. And it does that by carefully engineering the supply to the screens of these tubes. And I think that's what we're seeing with these 100 ohm resistors, is the result from the designers of this amp. So by putting in just the right kind of circuitry to the screen, it's really simple here, it's just this 100 ohm resistor, you can create a very linear amplifier. It's much more complicated than I'm making it sound, of course, and you can look this up on the internet and read about it. So far it hasn't helped me here in the situation that I'm facing. So the funny thing is, if you ignore the hum, which is hard to ignore, it's quite loud, and if you ignore the oscillations, which in many cases don't come out the speaker but sometimes do, this thing amplifies input signal okay. I haven't studied that very carefully because I don't see the reason for doing it, other than just to see if sound comes through. Sound comes through. That's where I'm at. I'm sure I've forgotten 5 or 6 more things I did. I checked the resistance of all these resistors as best I could. So deep breath, because here I go once again into the depths of this amplifier. So what we're going to start with is nothing hooked up to it. It's just sitting here. I'm going to turn it on. We're going to hear it. I think I'll take some voltage tests. Those are easy to do while it's still warming up. The next thing I'll do after doing some voltage tests, which I'll explain as I do it, so you can follow along. I'll show you the heating effect on the tubes. We'll see if that's really the case. Somewhere along the line I may have made an incorrect observation, and this is why I'm way off in the woods here. Maybe I overlooked something. Maybe a test I thought was proving one thing is proving something else. So who knows? Okay, let's switch it on. Here we go. So my expectation is it's going to warm up, it's going to make some funny squeaky sounds, and it's going to be a hum. Okay, full voltage here. Of course, it's had all night to think about it. So pop, pop. That's really curious to me. What is happening there? On startup, there's almost always a soft pop like that. This is working great. What's the problem? Where's the problem, Jim? Oh, here comes something. I'm guessing you can hear that. So that sound is coming out of this speaker. So there we are. There it is. So it's slowly changing pitch as if something is warming up. I have the inputs shorted out, by the way. They're shorted by shorting wires right up in here. So you can see that sound, whatever it is, has gotten really annoying. Okay, let's start making some voltage tests, because this is the way it's going to operate. First the B plus, coming right out of the power supply. 325. Okay, plate voltages on the 4 output tubes. And just pay attention to what happens to these noises as I do this. 307. 309. 309. 311. Now I'll show you the screen voltage. First one I'll do plate and then screen so you can see the comparison. Plate here, 307. Screen, 320. This way it's going to be all the way across. Now, part of this is because it's coming out of a transformer, right? It's just a bundle of wire feeding these things from the same voltage supply. So it's not surprising they all test the same. What it suggests is the screen current is the same in each one of these tubes. So what's the voltage on the other side of the resistor? Is it 320? 320. That suggests doesn't suggest it very strongly. It's only 100 ohms here, so maybe I'm looking for a variation in voltage that's greater than what it's going to be. Kind of make you wonder what a 100 ohm resistor is going to do in this circuit. And they've laid this out, I mentioned this before, in this amplifier they spent a lot of money putting these resistors in. Because they put in these terminal strips specifically for these resistors. Okay, so now if we look at the input side of the output tubes, we look at the grid. So I'm just going to go by and touch the grid. This will have varying effects too. Start over here. Have a little bit of trouble with my meter now and then. Let's try again. Meter battery's going dead. Hopefully this isn't part of the picture of the trouble I've had. I think my meter battery's going dead. A little indication. It's a dead battery on the 20 volt scale. Hear the difference? So now we got 2.6. You know, I really cannot keep up with this. This kind of voltage, 2.6 volts, I found over here earlier. And I investigated that for about a half an hour. And then it just went away. This is what happens in this amp. That howling sound's coming out of the left channel only. Yet I can... No, it's coming out of my cat, too. Yeah, what? Maybe they hear this and think it's a cat in here. I need some comic relief. I have a cat that's a... Hey, where are you going, kitty? Showing me where he wants to go. Okay, now the grids of the output tubes are fed through these capacitors. I've tested here. Like, what just changed? It gives me the impression that there's almost like a latching situation in here, where if a voltage gets too high, the operation latches into a different position, and then as I poke around, I somehow unlatch it back to the other. I don't know. Let's keep going, because it's only going to get stranger yet. If you don't think this is strange already. So now, on the other side of the 1000, I would not expect anything here. There's no source of voltage here except the tube grid. So if you read anything, it's the tube grid that's driving. Look at that. Yeah, so is it the tube grid? This has got to be grid current causing this. It would have to be, isn't it? 3.8 volts, other side of the resistor. 3.69. Come on. 4.1. 3.6. It's like a 0.5 volts across 1000. So, you know, grid current in here. Is there grid current to where? Where can it go? It's just a capacitor here. And what happened? There's no sound, no hum anymore. Everything's working perfect. Peanut. Really? Oh my gosh. Come on up here. Oh, no. Come on. Oh. Peanut. What do you think, buddy? What do you think? I don't think it's going to help me at all. Okay, I'm putting you down. He wants his morning pet. We have a routine where we go in the shower stall next to me here in the washroom, and I give him a big pet in the shower stall, and that's what he's asking for. His good morning shower stall pet. Well, it's operating perfectly fine right now. Let's mess it up. Okay, so I'm going to take some readings now. I'm going to repeat them right along the grids here first, because these should be 0, I would think. 0 or somewhat negative. I'm measuring this to the chassis. It's not a very valid way to test these. But consistency across them all is what I would expect. Look at that. So this is the not hot tube normally, but is that the case today? I don't know. We're going to check that out in a minute. And now going on the other side of these blocking capacitors. So what are they blocking? So right from the plate. The hum is coming back now. Oh, did you hear that? That was really telltale. It's telling a tale. It's telling a tale I cannot find. Again, this is working perfectly now, right? Yeah, it's working perfectly. Okay, usually I'll leave it on for a long time, but I have left this on for a long time, and it does not work perfectly. Let's carry on, because stuff is going to happen, I'm sure of it. 230, 240 rather, 63. 230, 63. Okay, so now we're going to touch the grid to plate connection in the input tubes, where it's a two-part tube. One half, the plate, is tied directly to the grid of the other half. Here comes the tone, the oscillation again. Start with this side, and the proper voltage here is 32 or 34 volts. Right? You just saw 15, did you? Did you really see 15? So that's correct. The other day I was doing this, and this 15 volts suddenly became 34 or 38 or whatever it was. There. Look. Look. Well, I'm glad I'm doing this demonstration, because I am sharing the wonkiness here quite successfully. That's 30, this one. At 20 now. Wasn't this at 30 before? That's 30. So there's something really weird going on up in here. Let's look at the tube temperatures now. It's been on a long time. More than long enough to stabilize these tube temperatures. Okay, I'm trying to get this on the little viewer here too. Great. Looking in here. Now this is set so things that look red have to be up around 100 degrees. So you see that's about 100 degrees, and that other one, can you see that on there? Again, it's not very good on the yeah, that's a little too far away. Now we're just seeing some tube bases. So what we're seeing in red are these two resistors. Two bases are not hot enough to generate a red color yet. None of them. Let's look at the glass tubes themselves. And of course this won't work because it won't. Because nothing ever works twice, right? You know, when you go to show somebody something. Oh! What the heck was that? What the heck was that? What? Come on, really? Okay, so what I'm wiggling here is an auxiliary switch I put in to turn this unit on and off, so I didn't need the receiver plugged in to turn it on and off. Otherwise, there's no way to turn this on. Tell me there's something funny about what I did here. So my assumption, this is maybe a really bad assumption. Oh my gosh, really? So I just stuck it through one of these screw holes here and mounted it to make it so it wouldn't flop around. It's just a switch. If I flip it, the set will go off. I screwed it to the chassis here on the assumption, the good assumption I would think, that this metal bracket here is not in any way connected to the inputs or the switch. Wow, it appears that this has come separate here. My solder job is broken. Okay, so I'm going to take this off, completely get rid of it. I'm going to put a straight solder, a straight short in the back here. Has this been my problem all along? Oh, come on, really? Come on. This is in tight as can be here too. So this is not breaking off. This is just moving some insulation around. Why would that be so incredibly sensitive? It's the power line prior to the power amp. It's the 120 volt line here. How can this possibly be significant in the whole thing? But, you know, I've been rolling around in my head here. There's something totally unexpected going on. You know what? I can use one of these. This is shorter. This is definitely turned off. Oh my gosh, if this changes everything. It's quite typical for an amplifier like this to not have its own on-off switch, but to be dependent on the receiver, of course. A little more copper here. If this is it, this has been the cause all this time. I don't know whether to jump for joy or cry about it. How can it be? How can it be responsible? How can this possibly be responsible for all this nonsense? Last thing I would suspect. That's why it's likely to cause. Ouch. It's a little hot. So this means every time I have this there's no auxiliary switch to turn this off anymore. This is just on all the time. I'll have to remember to remove this for sure before I hook up the when I go to work on the receiver, assuming I ever get there. One of the problems I have in making these videos is if I make a mistake that throws me off, like perhaps putting the switch in, I can do hours of work as I did. I could potentially post hours of video of nonsense only to find out it's all my fault all the way along, and I think you as a viewer may not really enjoy that. that's so when I'm doing these days, lately anyways, if I start getting off on some wild goose chase, I tend to not post videos. The result of that is I forget what it is that's on the videos, and then assembling them is hours and hours of work I can't afford to take. Hours to do it. So that's just the challenge of trying to do this documentary approach to doing this work. Sometimes you're documenting really disturbing stuff, I guess you would say. It may not be so enjoyable to watch. I do make these videos primarily for documenting the work I do. I share them on YouTube. Really, it only started by accident. People seem to be interested, so I continue to post them. I'm really not trying to tell anybody how to do anything at all. In fact, don't do what I do. Do your own thing. Okay. Now, this amp works totally different. Too much loose wire back here. Too much loose wire. Too many strands flying around. Stick them down here. When it comes time to relax, what I do is I go turn on the TV and watch how the behemoth country south of me is falling apart, and my country is bolted to the side of that country. You think that's relaxing? There's nothing relaxing about it. He says, frustration. I'm already expressing frustration this early. Okay, let's see what happens here. Get this. I'm gonna get this right out of here. Get this right out of here. You know, when I put this on, I just didn't think hard enough. I thought, okay, so the switch is no longer available. I'll have to put my own switch in. They just didn't dawn on me. I just throw a short circuit in. So the whole time this has been sitting here, basically doing nothing. Or has it really been doing something all this time? Goodbye to all that. I thought I was so clever putting that in there too. And my cleverness got me into trouble. It wouldn't be the first time that's happened. You know. What can look pretty clever at the start can look a little different in the end. Okay. Start it up and watch. No problems occur. Wow, if that happens on there. No, there was a hum to begin with this thing. Okay, everything's normal. Normal, normal, normal. Full voltage supplied. Pop, pop. Okay, so I'm going to guess these pops are these two tubes locking into their operating position as the voltages come up. There's the oscillation. This may be a warm-up thing. We'll just let these guys continue to warm up. I was getting ready to do the temperature thing, wasn't I? Long wires are So another possibility is these, I may as well do this. These speaker wires that I've run through here aren't supposed to go through here. They're down in this area, and I've got them running up right past the input. Having some effect, but I think it's the same effect as just loose metal. But I think I'm going to have to remove these and bring them in, or even put on, maybe I should put on the proper connectors. None of this stuff is shielded in here. Why would it matter? Just thinking of stuff. Okay, let's look at these tubes now. There. I'm going to see 4 equally heated tubes there. There's no difference. Come on. So this tube here was underheated for sure, and I swapped it out. I swapped it. I just swapped them, and I swapped in a new one, and it's consistent. Didn't matter which tube I put in that socket. It was running at half. Well, I don't know what temperature, but this is definitely not doing it today. Definitely, they're all hot today, and these two aren't even showing up. I mean, they're just slightly yellow. Well, the most exciting observations, bogus here. It's gone. I have it on video if I care to dig it up and show you. So my first thinking about that, when I saw this tube was cool, was that there's no plate current in it. But all the plate and screen voltages are the same on all these tubes. And it doesn't matter what position you put them in, you get the same result. So how can it be? So my next thought was, no, this is the normal tube, and these ones are all overheating from excessive plate current or something like that. And I just left it at that, because how can you tell? Too cool or too hot? I mean, obviously, you would normally think, well, which one is not like the other. So this is the guy who would be in trouble. Now, is that oscillation taking place just because these wires are hanging right in here? I can't believe it. I mean, it would make a dramatic difference from doing this, and it's not. It's just making a little difference. Okay, so at the current time, we've got all 4 tubes similarly heated. And I've got egg on my face at this point. But this amp has been doing this to me the whole time. We will once again measure the grid to plate connection on the preamp tubes. 29. 36. 15. 24. Somebody want to help me with this? 15. 36. How can I be doing that? Let's look on the scope, because we can get even more confusing information going in here. Yeah, so basically, if you haven't been gaslit enough by what's going on in the United States, watching this video won't help. Oh, it will help. It'll finish off your gaslighting here. Okay, so we're going to look first at the signal on the screens of the output tubes, because it's easy to do. Okay, that's a ground connection to the chassis. Screen number 1. Switch cameras here so you get a better look at it. Now there's a video effect happening. This pie piece that's sliding away, it just disappeared. That's a video. It just went dull. That's just happening on the video. That's not happening here. And certain things I just can't control with. There's too much automation in everything. So that's right on the grid of the leftmost output tube. Is it going to go across now? Screen on the next one. Screen on the next one. And there. If you notice this one, we're looking at the last tube now, the most rightmost tube. There's no center line in here. So it's nice and smooth. But when I check its brother, push-pull brother, I get that effect. Again, this lit part down here is a video artifact. Those sudden shifts. I'll do the other two tubes. I'll do the same tube in the other pair. We'll get the same look on the screen here, on the TV screen. Don't say screen. Except now you can see there's some, looks like audio information in there. The squeals we're hearing, or this could be a much, well, I don't know what to say. That's probably what we're hearing. It's coming out of this channel that we're watching on the scope is the one we're hearing the sound from. And now I'll go to its sister tube here, screen again, and then we see that middle track is missing. So I don't know the significance of this. I'm just don't know what I'm doing. Okay, so now we'll look at the grid of the output tubes, all four. There's a big signal there, right on the grid of the output tube. Seems to be folding over at the top a little bit. Okay, next one. Next one. So each channel appears to be operating identically when I do these things. Now we're going to look at the plate output. Right on the plate, starting on the rightmost tube. Notice each time I do these kinds of things, the screen totally disappears. And the hum has rid itself of it. There's no hum in this amp. There's also nothing on the screen. I'm on AC. It just must be just a huge whopper of a signal there. I'm on X1. Let me put it on times 10 here. Maybe we'll see something better. There we are. So that's the plate of the rightmost tube. You can actually see what I'm doing in the camera. So I'm going to go across now and look at each plate. Okay, so here comes its brother. Oops. And now the other pair. So they're all identical. They all show the RF. What I believe is RF. What else can that be filling in that screen there? Okay, so that was kind of a look at the output tubes. We'll go up here. First we're going to go right on the grid of these tubes where the signal would come in. It is shorted to the ground. Are they really? Oops. And the answer is yes, they are shorted. No question. So now we'll look at the plate to grid connection, the way these tubes are done. This is where the 34 volts DC should be sitting. So there's a high frequency oscillation there, but of course as I connect my equipment I change the operation of this thing, especially if we're looking for spurious oscillations. Every test I do, you can hear them, they disappeared in the speaker. But there's something there. go to the other tube, it's exactly the same. There has been very little exactly the same here while I've been doing this, so this is kind of surprising in a way. Let me flip it over to DC here. You saw that it drop a little bit. It's right between the two lines there. Here we go, the other side. Exactly the same when viewed on the scope here. Okay, leaving the scope in place and grabbing my meter. This is, I think 32 is the right voltage here, according to the manual. Voltage with the scope. See, I introduced the hum there quite a bit. 21 is what I see on that meter. On the other tube, same connection. 28. Remember, these things change every time you read them, though. Maybe not every time. How do we get the same DC voltage on the scope, but we don't get the same voltage on the meter? 28.7. 21. The difference between 20. Oh, I didn't see what's happening on the scope. So when I make this connection, it doesn't look like it changes the DC, it just drops that AC signal. Actual DC voltage would be right in the middle here, right? Oops. So this is probably part of what's been happening here is as I've been doing tests, I've been disturbing the circuit I'm testing, and so the result I see is the result of a disturbed circuit. That's why I'm so disturbed. I am disturbed. Listen to it, it's perfect. What am I working on here? It's totally hum-free. No oscillations. Take this off. Well, here they come. Yeah, the oscillation just went up out of my hearing range. Now this can easily be, there's quite a bit of heat just pouring up off the top of this. No wonder my furnace isn't running these days. This guy's heating up my house for me. Okay, so I looked over inside. I forgot to flip the camera on the video, so unfortunately for quite a while you've been potentially staring at my scope, but I cut out part of that. All I was doing, I think, is lamenting about the situation here anyway. If I could replace these guys, wow. You know what could have happened here? Is these capacitors do not have the outside foil marked. I don't think it makes a difference. These are high impedance at this end, super high impedance at this end. It's just going to a grid. This is really high impedance stuff. It's got to be why just touching it. It's like I've not even got my meter connected. I'm just touching the probe to it. It really strikes me whipping a capacitor in here. Now, if I whipped a capacitor in here, it would knock out those oscillations. So it seems. And at the same time, those oscillations are coming from way up in here, though. They'd still be going up here, wouldn't they? Wouldn't they still be going? The oscillations are only in one channel. Let me get a little bitty capacitor here. this is 110 picofarads. Holding it with my... That sounds really pleasant. Works here too. What's going on that scope? Let's put the scope on. We're gonna look way up the ground here. I'm gonna look at the incoming. I'm gonna look. You know what? This pin is grounded through a resistor. I never noticed that before. That's supposed to be a 68K resistor right to ground. Right off that pin. I missed it. I missed testing that. I'm sure I missed testing that. So open ground connection is a real likely thing here. Causing these effects. Missed it. Uh-oh, my computer's telling me I'm running out of storage space. Quick, let's do this quick because it's going to run out really quick. What do we get here? 68K, it's got to be up here. Hurry up, man, that video's going to quit any moment. Maybe open. I gotta stop the video. I gotta fix my computer. I'll see you in an hour or two.